All right, good morning, afternoon, evening, whatever it happens to be where you're at. So I will try to record these as much as we can. Every once in a while, technical failures are going to happen, but we are a blended class, which means we have a couple of students on campus, and this semester, the majority of the students are online. It's a weird semester with COVID still raging around, and I suspect there's a lot of students who have enrolled online just out of that sheer paranoia, and in some cases, rightfully so. So the first thing I want to do really quick is look at our syllabus and take a look at what we're going to try to do. There's some things in here. This is the first time we've used some of these Cengage tools, and so I will tell you that up front there may be some things that will change as we progress through this semester. So this syllabus template has changed a little bit, so if you're used to last year's, it has changed just slightly. So really the syllabus is nothing more than a map of what we're going to do. And again, I said there's probably going to be a few changes, so bear with us on that as we go through some of that. So who am I? So weirdly, when you enroll in these classes, it shows up as some guy named Kenneth Griffin. My parents decided to add the Kenneth or whatever named me at birth, and then promptly never used it. So my legal name is actually Kenneth Bradley Griffin. The only place it shows up is on my driver's license, and when you go to enroll in school and such, it shows up as Kenneth Griffin. So this is me. If some of you, I'm your advisor. If it shows up weird, I apologize. That's something that they apparently can't change in our system. So my office is actually right next door to the computer lab if you're here on campus, or TJ Majors 202. And as most of you know, we post these office hours, and we're generally here a significant amount of time in addition. On top of these office hours and other things, if you email and try to request either a virtual or on campus or phone meeting, we will try to accommodate that as much as possible. I will even try to accommodate evening requests if possible. I have a 9 and a 10-year-old, and sometimes that precludes that, but we will try to do what we can. My phone number, after the last 14 or 15 years complaining that it's the worst way to get a hold of me, now we actually have voicemail, and the phone system is a little better than what it was before. You can leave a voicemail on there, and the voicemail will eventually work its way to my phone with a email. It's probably, if you need to get a hold of me as quick as possible, it's probably quicker to send an email. My phone gets it, and I look at it, and I tend to respond at weird times. If I wake up at 1:30 and I see a message, I'll try to respond to it. I will warn you, if you see one of those at 1:30 in the morning and I'm responding, don't judge me on my spelling as I'm typing on a phone, blurry-eyed and such. So contact me anytime. I like answering questions. That's what I'm here for. If you have questions about our program, somebody else's program, classes, whatever it is in the world, I can provide you with anything except a winning lottery ticket number. So the physical class meets from 9:30 to 10:45, Tuesdays, Thursdays. If you're online and you want to attend a class, feel free. You might send a note and just to email us and say, hey, I'm going to be here, just so I know who it is walking in the door, but you are certainly welcome to attend. We will try to record as many of these as possible, so hopefully it's not quite the same as being here, but at least as close as we can get. The Cengage Unlimited is what we're using for this particular course. We've kind of standardized that in our CMIS classes. That way, if you have multiple CMIS classes, you only have to buy that Cengage Unlimited once. If it's the only class, well, then it's still not as bad as some of the textbooks. So I think right now it's $119, and I wish they would make it cheaper, but if you've bought books for some other courses, and I know some people that are in like the biochem field and such, those books are incredibly expensive. So what do we require? The softwares we will provide, or we will show you what we're going to use. You should have had CMIS 101, but really that's just kind of our gateway course in. So we're going to talk about things like programs, algorithms, what languages we're going to use, solving techniques, sorting. We may also look at some other new and exciting issues that are coming out, and how do we deal with those. And when you're done with this, I hope that you can do things like a structured algorithm, and not necessarily because you're going to be a computer programmer, but maybe we can set up some logical problem-solving skills that you can use to outline business problems or other issues. So you have some solution models, some strategies how to solve that. Now, we're based programmatically here in the business school, so we might lean a little bit towards business problems. And then we want you to be able to be empowered and think about what's going on. Because once we introduce you to some of these things, I hope that sparks that interest and you say, man, I got a little taste of this. I'm going to go online and I'm going to go to the Coding Academy, or I'm going to go at any number of different ventures, and you can go out and branch out and learn as much as you would like to. So typically I'm not going to lecture for the entire period. That doesn't really fit this modality of this particular course. This is one that you do have to be hands-on. And so if traditionally you've only taken lecture classes where at the end you had a quiz and maybe a midterm, this is going to be a little different. You have to get your hands dirty to be able to do any coding. There's no other way. Your brain has to be working on it. So I do ask that you guys, I know we're kind of a mixed class and online, we're going to have some discussion boards and other events. Be kind to each other, but remember sometimes being kind, because one of the things we're going to do later on is you're going to get to evaluate each other's codes. Kindness is also being truthful. If something doesn't work, telling them, hey, that was a great job and it seems to work really well, but it doesn't, isn't really being kind and truthful. So, but there are ways to do that where you're not bashing people. So be respectful to everybody else. I will say that one of the issues with this class is, since in a lot of cases I want to push out solutions and ideas and thoughts, due dates are not negotiable. Now, if we have something happen, a natural event or something else, and there's probably a time when, for whatever reason, we may change a scheduled date, but late assignments are typically not accepted. Once we publish a solution, it's hard to say, hey, go turn this into me. So if you're on campus, just a reminder that face coverings are required. This class, again, we're spread out, so it's probably not quite as big of an issue, but remember, on campus they are required everywhere. Must participate. So while I don't give credit for just being here, but listening to the lectures, looking and trying certainly is a piece of that attendance. So every week there's going to be some kind of discussion board assignment, and then we're going to use Cengage, and we're also going to use some outside of Cengage assignments. And then about every 2 weeks there's going to be a short quiz, as we've kind of structured it. There is going to be a midterm writing assignment. So you're like, wow, I'm in a programming course. Why am I doing a writing assignment? It's all part of that critical skills, how to get this information processed in your brain. And as we get to that, I'll explain some more details about our writing project when we get there. So at the end, there will be a final exam. It's only available at the end of the semester, and we'll talk about those restricted dates when we get a little closer. Weirdly, this class is going to have a lot of points. Primarily, that's driven by our use of Cengage. Cengage decides that every assignment is worth 100 points. When it interfaces with Blackboard, it pushes data across. I can use Blackboard to try to modify those point values or modify them inside of Cengage. What I discovered last semester when we did that is that process has some badly broken flaws. So we're just going to adapt to Cengage. The end result is 90, 80, 70, 60 grades are still the same. It just means you have a lot of points at the end. So what we've done is then I bumped up the exams then to 1,000 points total. Your paper is 500 points. Discussion boards are 1,500. So we've got a lot of mix of different assignments and different things. So even if you don't do really well on a couple of assignments, you can still do well in the course. There are a couple of caveats. You do have to attend the final and take the final, and you do have to do the midterm project. Those are required for passing this course. So attendance. So this is a new piece they've added in after last semester. One of the problems that we ran into, students would test positive or be exposed, and they would be in quarantine and then never show up again. They seemed to disappear into some kind of black hole. What we discovered is students who tend to disappear don't tend to turn in materials. People who don't turn in materials don't do really well at the end of the course. So the other piece is we will probably yell at you a little bit if you're missing assignments. We're going to use the Bobcat 360 if you're not aware of it. So be aware that if you're missing things, we'll probably yell at you a little more than we normally would. So there's a discussion about how we can do makeup work. And they also talk about not doing Zoom as much. But in this case, we record everything simply because we're the nature of this course. Late assignment policy, we talked about that a little bit. The Bobcat 360. So don't be surprised if you see something from that. We're also doing attendance through Bobcat 360. So online, we don't necessarily take attendance, but if you're taking some on-campus ones, you'll see that we're using that feature. Grade appeal. If you think that I have graded you unfairly or done something in your grade, not simply because you have a B+ and you wanted an A, but if there is a reason, so I treated you differently than other students, there is a grade appeal policy. Course eval, at about 2 weeks or so prior to the end of the class, we have a formal class eval. I tend to ask some questions throughout the course also and try to see how people are doing, what we can do differently. And as we're throwing out some new material this semester, you'll see me ask questions more often. We want to know your opinion. We want to know how you're feeling about things. I will say, posting on the eval that I would like a class with no homework probably doesn't always work. We take that a little differently. But it is your voice, and we like to hear from you. And if we're doing something really horrible, tell us immediately. We don't need to wait until the end of that. Most of us are really, really flexible, and we like to hear what's going on in your brains. Disability services, there's a contact number and email. If you fall into those categories, it is a great resource we have, as is the tutoring. Now, the tutoring we do here is a lot of times peer tutoring. This course is different than the way we've done it previously, so it may be interesting with peer tutors. But the tutoring model also gives you the ability to learn collectively. And so you can form study groups if you need to, and sometimes that's really effective. And now with all the virtual tools, you can do a lot of that if you need to. Little caveat as we head down into the academic integrity policy, collective learning doesn't mean collective one single assignment. And so you'll see that there's some errors in there that we need to work with. Equal opportunity notice. We will treat you all equally. That is my hope. If we are not, let us know. If there is something that we're doing. So we're now coming up with some captioning tools and working on it. So as an example, I had a semester a couple years ago, and I had a student, and I posted a lot of material, audio recordings, and I had a student not doing well, and so I started inquiring with her, and via email, she said, well, here's the problem. I'm hard of hearing. I can't hear when you talk. And I went, oh, well, let's rearrange how we do things a little bit. So we need that to know what's going on, and sometimes it's not always as apparent. So the equal opportunity notice, we really are trying to be as non-discriminatory as possible. That doesn't mean that you can say, man, I just don't want to study. No. There are times that we have to pull that, but we try to be as equal opportunity as possible. The tentative schedule I did not put in here yet because I'm still working through, and I want to get some experience with students, how long it's taking to do some of these assignments, because we may rearrange a little bit, because I do try to keep it the class time expectations. So we use something called the Carnegie model. The Carnegie model says for a 3-hour course, we should engage you for about 135 hours total. So that's in-course time, that's time you're spent reading, that's preparing for quizzes, doing assignments. It doesn't mean that when you hit 135 hours, you stop working on the class. And it really is kind of an average. And we all know averages can be very deceptive. So there isn't really an average, quote unquote, student. You guys can't see my air quotes when I did that. But as an example of why averages can lie, if I have 1 foot in a bucket of boiling water and 1 foot frozen in a block of ice, on average, I'm comfortable. But am I really? No. So some students may take less time. Some students may take more time. It's our best guess at an effort. And so one of the questions I will sometimes ask as we go through here is how many hours you've spent working on things. And hopefully you're honest. And we can actually reflect on that a little bit. And then as we go through and we redevelop materials, we get closer and closer to that target. But there's no way for us to always know that every student is going to work exactly 135 hours. You may have some student who manages to breeze through and all they put in is 75 hours. The Cengage does give me a little clue because I can actually at some points pull some reports and see how long you've spent inside of some of these assignments. And so if we run into some roadblocks, it gives me some metrics. If you run into issues in this class, send me an email, call my office, send me a text. Well, I don't really have a number up there you can do that, but I will send you a way we can do that. Let us know. And that's kind of one of the key features here. So, enough with the syllabus. So you'll notice there are a lot of links in here. These links, any of them that have this weird little circle of flowers on the left, are a link into Cengage. You will need to purchase the Cengage Unlimited fairly quickly, like now would be good. And what happens then is that link will take us directly. If you have not purchased it yet, and you're on a short trial period, which my understanding is their trial period is getting shorter and shorter, unfortunately. When you click on the link, it will just take you into the course, and you will have to actually search for the individual assignment, which makes it a little less convenient. So when I click on it, it'll slowly load. So this is the book that's behind there that we're using some. We can use other assignments, and one of the great things about Cengage Unlimited, if I wanted to use 6 books inside this class, all from Cengage, I can do that. So Cengage is got a great platform here for us. This is the book that we're using kind of as our backdrop in there that you're going to have for information. Couple of notes about Cengage. If you are on a Mac, and some of you probably are, you have to use Firefox or Google Chrome to run Cengage. It will not work in Safari. Pieces of it will work and then it will fail spectacularly or it won't even let you in. So you have to use Google Chrome or Firefox. That also applies to the PC or if you're running Linux, if you're on that side of the market. Either one of those should work with this particular software. It does need some restrictions updated. So if you click on there and it says, I need to enable pop-ups, there's a lot of information about how to enable pop-ups. I hate pop-ups, but it's unfortunately that's how Cengage wants to function. You can make exceptions just for Cengage. I will point out something in here. I have all kinds of things turned on Cengage's side. The only things that are actually your assignments, so if I make them completely disappear, I can't use them later if I want to try something. Only the assignments that are linked out of Blackboard are actually counting towards your grade. So you may come along and you say, oh, here's a pre-course assessment quiz. Now, we haven't started Python, but if I had a student who came in and said, I had 3 years of Python in high school, hey, let's do this pre-assessment quiz, and let's see how your skills are. Maybe you can get out a part of the course. Great. So, not everything that has an orange dot, if you're coming in this direction, is actually going to be an assignment that's graded. Only the items linked in Blackboard are graded, and I'll show you what those look like here in just a second. So, from my side, hey, there's nothing graded yet. Great. So over on the right-hand side of this, for those of you that have not used Cengage Unlimited, probably the most useful tool is over here on the right. And that is, we can launch this full copy of the entire book. So when I say read pages whatever, this is where you can go to do that. Is it as easy as holding a physical textbook in your hand? No. The one other advantage to Cengage Unlimited, if you want a physical textbook, and quite frankly, I tend to prefer to have a physical book because I like to highlighter and draw all over and do things, they will actually rent one to you for, I believe it's $7.99. So it's like a textbook rental, and you get the electronic component in addition. So you may want to do that if you're comfortable using online materials. Everything is here, and it does allow you to jump back and forth. So I can jump into things and say, oh, I want to look at, never mind, I want to go to page 57. And so you can look at some of these items here, and you can jump from one particular area to another. Again, I like a physical book in front of me, but this is really handy because I don't have to carry it around. The other issue, if you happen to get a physical book, and you're saying, man, I need page 37, I will warn you that sometimes the paginations between the online copies and the electronic copies are different. Because the online copy can shrink and grow, and depending on font sizes and other things. So sometimes the paginations are a little off. So I will try to make sure that you're aware of anything that I run into that's very different in here. All right, so I'm open into Cengage. Notice I didn't have to create a login or anything, because once I've created my initial login into Cengage and bought that Cengage Unlimited, it links directly from Blackboard into the tools that we have. So there's a couple of pieces in here. So this one's just a link to the entire course. If I want a specific assignment, when I click on it, ever so slowly, it will bring up some of these. So for example, the crossword puzzles I typically put up because it's an interesting model, but there's no points on those. Even though it says there's a score, these are just a practice. So it's a quick way, and for some people these kinds of things work really well, but it's a way we can do an assignment, learn some vocabulary. And again, I can get out of that, click. So there's a practice puzzle. Here is, I'm going to look at some slides. They're also linked directly in there, so I didn't change them. I left the ones identical so you can see. These would be in a small window. And then we have these coding assignments. And here's where I do get a little frustrated with Blackboard and its constant rearranging of things. So the assignments actually start with 1.1. So I pulled them all back up, rearranged them in the correct order, and Cengage/Blackboard in their infinite wisdom said, oh no, nope, we're not going to have that. These are the order we're going to list them in. And I went, okay. So I want you to be aware, and we'll look at why programmatically, why this happens. Why does 1.10 appear first when it's actually, when we come down here, it's going to be the last assignment you do. So 1.1, 1.2, 1.3, 1.4. And so we'll show you what those look like. And there's a programming environment inside of Cengage, a little simulated environment. So we're going to look at what that looks like. This is the first time I've tried that as a coding program. Before, we've all used exclusively, we've ran at what's called a compiler, and we'll talk about what those are. And we're going to force you to download a compiler and run it. But inside of here, it gives you an environment where everybody's even. And so we'll take a look at that. Reading, there's some preview. Data files, if you need them for any of the assignments, are here. So I've got a link to the entire data files and ones that says just download the ones you need for this particular chapter. And then all the way down at the bottom, this is I guess you might want to call it the hard copy version of the embedded PowerPoint. So I want to talk about some concepts really quickly, and then we'll show you this programming environment. So the first week, I know some of you are still working on getting the materials. Come back here. So I want to go over some ideas and some concepts, and then let you loose to read and start working on some of those programming assignments. So why do we care about any of these things? Computer science, what has it done for us? What has it done for us? Do we use computers anywhere? You have one in your pocket, I'm going to guess. And we do everything from checking our social media. We can use it as a calculator. You can send messages. Occasionally, you may even use that phone to call somebody. So we use all these tools and techniques everywhere around you. Your car can't run without computers and software. Everywhere around you. Your thermostat in your house is a computer. So understanding how some of these items work and some of the concepts behind it, I think is pretty important. So we're going to look at information processing and the idea of something called an algorithm. And an algorithm is really nothing more than a set of steps to solve a problem. So I'm going to pick on you because you're here and you're a math major. You do that all the time, right? You have to create a structured set of how do I solve this math problem? And in some cases, you're given an algorithm to say, all right, I know I need to solve this problem with doing steps 1, 2, 3, and 4. And once I get that algorithm, no matter what numbers or items you're given, that algorithm then will process that data the same. So I fight with my 9 and 10-year-olds all the time in their math because they want to just look at it and say, well, I know it is, it's my brain, it's here. No, I want you to develop that algorithm so when you get a harder problem, you understand how to actually solve it. Well, the algorithms are behind the scene. They're what we do, those steps that we look at. So for us, if we go back to grade school math, if I want to subtract two numbers, well, we know, hey, we write down the numbers. The larger number is above the smaller one. Yes, we could subtract and get negative numbers. I already saw that look. But so in this case, we're going to say, all right, we want the bigger number on top of the smaller number. We know that we need to line them up with the same columns. And we subtract in an algorithm. We know that this is the way we can subtract those numbers. Whether it's a 4-digit, 5-digit, 6-digit, 72-digit, it would actually work the same. We've built an algorithm and we've programmed our children how to subtract. So that sequence of steps, or how we problem solve, is called that algorithm. So it's not some big scary mystery word. It just really means we have a solution. So what are some features we know? It's got a finite number of instructions. Each instruction is well defined. And we have that because if we just wrote it open-ended, it wouldn't actually help us much. And then it has a process that halts at some point because we know when we get done, it's got to have some way to stop. And so we're going to create a lot of algorithms in here on how to solve small problems. So the other side of that is this idea of computation, processing. So I'm going to argue a little bit with some of what our book says, so beware. I am going to argue that information and data are not the same thing. Data is raw facts, at least in my brain. Data is raw facts or raw numbers that have no conceptual meaning. They don't give you any additional value. So in business, we're always looking at that idea of additional value. When I process data and it gives me value, then it becomes information. So data is raw, information is processed. So let's think about data that's raw. the number of votes on each political party's candidate for the election recently, that's raw data. That's data. When I process that and I say that translates into this many electoral votes, then it's now information. It's processed. It's become useful. So our computer really does this. Takes a piece of input, transforms or processes with that algorithm, that set of rules we created, and it sends out some kind of an output. So that output becomes information. So you could think about it as from raw materials. So if you think about it from a car example, from digging iron ore, that's that raw data, to the finished, what kind of car do you like? He's like, I don't know. Ford Mustang? Sure. Ford Mustang out the end, that's that information. So we started with raw, we ended up with something that's usable. So now we do that with all different kinds of things. Images, music, video. And when we look at what things are transforming around us, things like video are now very transformational. The world has changed around us. We're using user-created videos. And now you can get stuck on TikTok for hours watching videos. Somebody took that raw data, they recorded themselves, modified it, and it became an output. So our typical computer today has two parts. It's got a hardware and it's got a software. They both depend on each other. So I can't run the software unless I have the hardware. The hardware without a program is useless. If you went out and bought a new computer and you didn't buy Windows or Mac OS X with it or Linux, it's just going to blink at you. It doesn't know anything to run. And so that software then is what actually accomplishes that task. So software is really a very complex set of algorithms. So when I have Mac OS X, it's really a set of algorithms, problem-solving steps, all compressed into one. And it allows our computer to do something. So if we break it down a little further, and some of this may be very elementary for some students, for some it may not, your computer really takes in data. It can process it, so it uses something called a CPU, or a central processing unit. That's if you look at a computer and you go, I got to go buy a new laptop, and I don't know if I need the Core i5 or I need an AMD, whatever, Ryzen processor. That's the CPU. That's what does the work inside the computer. It's the engine, if you want to think about it that way. That engine takes information in, so somehow you put information in, whether it's you typing it, you talking, it opens up a file, it pulls it off the internet, however it gets it, it changes it with our software that's running, and then we'll send it out. So maybe it puts that data out on your screen, it prints it, it sings, whatever it is. The other piece that's important in there is that memory. And the memory is important for us because we're going to interact with the boxes of memory that are on your computer. So somehow it's got to store this data. So it takes data in, moves data out, and it does that by this connection between that CPU and the memory. So our computers are really, really dumb. We think they're smart. They do a lot of things for us, but at the heart of it, your computer is really dumb. It is a light switch. It can only store data in zeros and ones, either on or off. An electrical signal is either on or off. That's at its heart. That's all it can do. Well, it presents some problems for us because we don't think in binary, in zeros and ones. We think in decimal. Our brains are programmed, and we've done this so long that our brain thinks in terms of 0 through 9 or 10 possible digits. So you're going to see this idea of binary pop up several times. The other term you'll see that is on all kinds of devices around the world, when you see the term digital, digital means it's computed, it's broken down into individual little packets that are stored as zeros and ones. So if you have a car that has the letters digital braking system on it, that means it's using a small computer. It's taking that information, breaking it into zeros and ones, and then outputting the results. Well, there's two different kinds of memory. So random access memory, or RAM, is your first line storage. So on your computer, if you power it off and you had a program and you're writing a paper and you power it off, that paper's gone because it was stored in random access memory. So the random access memory and the processor work together. That's where it stores the results, stores its data as it's processing. Random access memory is the fastest memory your computer has, but it's also volatile, is the term that we use. In other words, it disappears if we lose power. Now, if you're using a laptop like most of us are, that's less of an issue because it's got a battery built onto it. But if I pulled the plug, restarted my computer, that's what we call volatile, random access memory. The second type of memory is we tend to call like permanent storage or semi-permanent. And so it can be all different kinds of things. Typically, it's what we call a hard drive on a computer. But the hard drives are changing. They used to be spinning platters, and now they're solid state. So in other words, they don't have any moving parts. It could be an optical disc we could be storing things to. Could be magnetic tape if you see the 1960s movies where they have the big reels of spinning tape in the computer data centers. So it's a way we store data that is non-volatile. Lots of different ways we can store it. It typically is much larger than our RAM memory, but it's also significantly slower. So we talk about when we program, can we keep it in random access memory to process rather than having to store it to the external drives back and forth because it can actually speed up our process. So our computer thinks this is what memory looks like. So we have buckets, and those buckets hold a set of zeros and ones. In this particular case, the way this is set up, each cell holds 16 zeros and ones. Typically, the models will be either 8 or 16 bits. That's what we're storing. At the very bottom end, we're storing those zeros and ones. Everything we do around us is now down to these zeros and ones, and we figure out how we get data in and out of there. And so that cell has a finite size. So in this case, it's what we're going to call 16 bits, or 16 different data points that can be stored in there. But a single 0 and 1 doesn't do us a lot of good. All it can tell us is on or off. So we typically break data into a couple different things. And you'll hear me talk about that over the semester in a lot of pieces, that the idea of binary comes in, and then we break them into groups. Typically, what we actually break them into are groups of 8. So each individual 0 or 1 in there is what we call a bit, a BIT. When we break them into groups of 8, they form what's called a byte, B-Y-T-E. So and a byte is the smallest usable piece of data. So 8 bits makes it actually usable, and we can create one character in an alphabet or something with that. So just the start of this, we'll talk about it a lot. So computer software. So when your computer starts up, it's got to run something. Most of us probably have a Windows PC, maybe we have a Mac. That computer operating system is what starts first. So, in a weird little twist, there's another little piece that we typically call BIOS back behind there that tells it what to load. So, but it goes out and it gets this code. And that code is stored as zeros and ones. And it says, oh, I'm going to load it into memory. And then I'm going to run. So the very first thing you're going to run is that operating system, whatever on your computer. And then on top of that, we're going to run what we call applications. So your web browser is an application, word processor, spreadsheet, database, terminal emulator, graphic packages, whatever you run on your computer, that's all setting on top of that. So right now I've got PowerPoint open. That is an application setting on top of, in this case, Windows 10. So we have some languages. And we'll talk about some of them. We've decided in this class to use something called Python to use. We could have used a lot of other languages. And in fact, your first discussion board talks about that idea of, did I pick the right language for this class? Who knows? There's arguments for all different kinds of things. So I explore you to find those arguments. We have a couple of different types. So you have what we call a high-level programming language, and you have a low-level programming language. Low-level would mean we're actually writing those zeros and ones out at the very basic level to get the computer to do what we want. High-level says it looks like English. Well, I don't know about most of you, but I speak English better than I can speak zeros and ones. So high-level programming languages. And so Python is what we call a high-level programming language. Looks like English. We express, or we look at those algorithms. We can start to make sense of them pretty easily. We create them in typically some kind of an editor. So we'll show you a whole bunch of those through the semester. And then that program goes into something called a compiler, or in this case they called it a translator. And that translator or compiler takes that high-level language, reads it, parses it is the term that they use, and creates code that can actually execute. And so it creates code that then runs after it scans through the whole thing. So it looks for a lot of things like syntax errors and other things. If it then passes through all the checks, then it can actually run. And so it'll run our software. And you're going to see that in what we're doing. So we have some form of editor, passes into our conversion program, and then it actually runs that program. And that program may take inputs, may output something, sends out error messages. Because even though we have the syntax correct, in other words, it looks like a sentence, does that mean it's logical? Not necessarily. So, real quick brief history of the world. So, long time ago, they used abacuses and other things back. In the 19th century, we finally got some. We had Babbage's Anatical Engine. We had some punch card machines. In the 1930s, after World War I, we started looking at, we could practice and control some of this data. In the 1940s, early 1940s, late 1930s, we were starting to head into something called World War II. I know now it's been a long time ago, but one of the things that they were trying to do was predict what was going to happen, target bombs better coming out of airplanes. And so some of this came out of the Defense Department. And as you'll see, a lot of applications as we go through here came out of Defense Department. So the 40s were our first electronic computers. The 60s, we finally started getting up where there were some things that were happening that were more exciting. And if you go back and watch some old 1970 shows, you'll see the big computing centers. And they almost always have these big reel-to-reel tape decks spinning data back and forth. As we progressed, life gets a little better. Our computers start to become networked. They start to get small enough that we can move them with us. And now we're to the point where everybody's got literally a 1970s supercomputer in their pocket. So things have gotten smaller. They've gotten more interconnected. I'm not necessarily sure everything is really a good piece of that, but we'll see where we're at. So, streaming of music and videos. Well, I just saw that almost the last video store chain is now finally closing because who rents videos anymore? So, there are a lot of disruptions in the world around us. Think about those people that used to make yellow book or the Yellow Pages phone books. When's the last time you saw a phone book? Not recently. But it's kind of nice. We can go on Google, we can get a phone number, we can do all kinds of things. We put computers in the cars. Now you can have Alexa in your car if you want it. So that's kind of the quick history. I'm not going to get into a lot of details today. I'd like to move on and get you started on our next system because I want to get you familiar with Cengage today. So, excuse me while I sit so I can type. Let me log out of here really quickly. In your assignments, so remember that this is kind of weird because they go backwards and we'll see what happens. I'll move it around again. We'll drag this one all the way to the top. Come on. There you go. All right. So I'm going to click on this 1.1 and I'm going to open it up. And it's going to take it a little bit to flip into the right assignment here. So the first thing it does is, hey, your first try for this. So the way I have got them set up is you can actually do these an unlimited number of times. So you are not going to get punished by trying something in here. And that's one of my goals is we don't want to punish you for that. So I'm going to click Start the Assignment. This may take a little bit especially if you're on a slower connection. All right, so there's all different kinds of pieces here. Yes, okay. Yep. And it will guide you through some of these. All right. So over on the right-hand side is our actual where it's going to run at. So when we do, in a couple of weeks when we download it to your own computer, you'll see that it'll look slightly different, but now we put all the pieces together in here. So if I write a piece of code, and so I'm going to start out with a print statement in this environment. So I just put in here print hello. And now I want to run it in this sandbox environment. I click the run button. And it's actually going to run. And it says, oh, there's my program. It said hello. So my code over here, this is my text editor. This is where it actually runs in. And it will also alert me to things if I do something wrong. So I'm just going to back out a couple pieces and I'm going to try to run it again. And it's going to go, oh, there's an error. So no end of line while scanning string literal. So sometimes the codes are not as easy to understand, but it will hopefully point you. So the other piece that it will tell you is it says line 2. So it found that error on line 2. And so as we start working on that, as we start working our way through those, you'll start to see these errors will almost always go up and point to a line. That doesn't mean that the error is actually on this line, though. That's where the program encountered an error. But oftentimes, I'm going to have you look above that, because if I forgot to put for example here, I didn't put a second quote mark on hello. It's going to cause an error, but the next line is the one that's going to cause it to. So because it doesn't have this end parenthesis or end quote mark, it doesn't know where to stop. So it's going to try to run that as one big line. And so notice it says, all right, the error is on this line, but it's actually caused by the line above it. So just be aware of that. If you've done the HTML classes, you've probably run into that, where the error typically is ahead of the exercise or the issue. So there's a lot of these assignments. The other thing I want to point out here real quick, so now I'm just back in the generic class. So basic Python, all these coding assignments are actually inside of here. Notice here it actually codes them correctly. I will also allow, there's some sample ones, and I will pop those up as practices for you to give you some experience working on some of that. Before you can do anything at all, though, we really need you to read this textbook. So that is your coming in here. Oh, it's in the other window. And I need you to read chapter 1. And so chapter 1 has a lot of content in it. Notice I can jump to, I can actually go to the table of contents here, and I can say, all right, basic Python programming. And so all of these pieces are in there. So when I just did a print statement, it talks about it in there. So we're going to have a couple of weeks to get through most of this, and it may take a little longer. So that's why I've kind of done some of this open-ended. So it will talk about modules and programs and scripts and terminology. So here is an example of a program right here, and they will actually show you how that runs. So in this case, we're going to get to this point of running a program like this. So this one said, all right, I'm going to play a guess the number game. So first thing this thing does is it imports something called random. In other words, so we can get a random number generator. Here it creates a couple of pieces. So it says, if it's smaller, larger, my number, so we're selecting what the user puts in. And so we're going to talk about those loops, but I need you to start reading through the content. So don't look at this and go, oh my God, I can't do this. You're not here yet. No, I don't expect you to be. What I want you to do is start looking at how does Python work. So what we are doing is we're doing this inside a Cengage for now. There is a Python environment. So Python's idle. So we're going to have you install that in the next couple of weeks. So if I run, they talk about Python idle. There it goes. This is Python's idle. So this is what you're running on that right-hand side of the Cengage environment. So this one is running locally instead of being inside a Cengage. And it does the same thing. So if I say print, hello, it echoes back that return. I also have a text editor in here. So now I've got the text editor version. So same thing. So when the book talks about this idea of using Python's idle, that's what we're looking at. I want to show it to you in Cengage first, and then we'll start working on how to get it to run on your particular computer. Python is free and will run on any computer. I don't know of one that I can't get it to run on at this point. Maybe. Sure, somebody will find one. But I know we can run it on the Mac. We can run it on the Windows. I've got it running on a Raspberry Pi. If you're running a Linux box, it's actually defaulted in there already. So I need you to read all of the material, and then we can start examining some of the content as we go through there. So I will start creating some videos in class and out of class to show you how to do some of these pieces. But read through this material first, and then we will go through some of those concepts and hopefully help explain them a little bit better. All right, so for this week, we really have 2 weeks in here is the way I broke this up. So it doesn't end until 1:24. If you wait until the last minute to start on this, you're going to be in trouble. But we have several of these programming assignments to do. Most of them are actually really short, but getting used to building that and working on it is kind of key. So you cannot wait till the last minute. If you have questions, we need to do it immediately and get moving on that. So The first week, though, I do have a discussion board assignment due at the end of Sunday. So, and that is this one here. So I need you to introduce yourself so I know who everybody is. And then the question, I chose Python. You need to go out on the web, and is there a better language I could have chosen? Pick an alternative language and defend your choice with at least one source. So when I put in that source, I need to list why they thought it was more appropriate. So you're going to paraphrase their comments and your own comments. And then you need to list the source of where you got that information. The other thing you need to do is you have to respond to at least one fellow student. So fairly quickly, we're going to get where you have to do 2 posts. But this first week, to get you started, you need 1 post. So I will send out some reminder assignments on this. Make sure you introduce yourself and make sure you have read the book as quickly as possible. All right, so to join the book the very first time, so once I get my Cengage Unlimited account, once I click on this link, it will link me to the book. So if I click on this, now I'm in the book, and it may ask a couple of questions on your side, but at this point, I now can see who's already joined in and in this book. So I could go to Gradebook and go, all right, I see these students have already gone in, and they are now connected into, so these assignments will all directly launch from here back into Blackboard. So if you look at Blackboard then, I will see the same thing. I can then see those assignments inside of here, and it links the two together. I will say it does not always do it perfectly, so if you run into problems, give me a text, give me a phone call, give me an email, and we can try to get that corrected as quick as possible. Getting used to that Cengage environment is going to be new for all of us because I want to just fire up the idle environment, but hopefully this is a little better way. It'll give you some hints and it'll give you some tips along the way rather than leaving you just a blank white screen and you not having a clue where to start at. All right, good luck, and I will send out some other announcements and try to poke you into the correct locations.